Hi, in today's session, we're going to be talking about TLS and how it really works, right? A deep dive. So, just to start off here, before TLS, there was SSL, Secure Sockets Layer, and that got deprecated over the years because it became insecure. And then it evolved to TLS version 1.0, 1.1, and 1.2, and there's also version 1.3. Um, TLS stands for Transport Layer Security, and essentially what it is basically a means of creating or setting up a secure connection between the client and the web server. So just think about it: if you're surfing the web and you want to actually use a secure means of using a web browser, you're really using TLS here, right? So TLS works over TCP. HTTP, the web traffic and everything, uses TLS to secure all your traffic confidentially between the client and the server, right? So what we're going to be doing today is we're going to be talking about TLS in the context of RSA, right? So that's just to keep in the back of your mind. I'll explain RSA a little bit more later on. But for now, just note that TLS operates at the session layer of the OSI model at layer 5. Okay, now our goal with the TLS is basically a couple of things here, right? So we want to basically establish or specify the TLS version. So in this case, it's going to be version 1.2, right? And we want to agree on some cipher suites, right? So that's part of the whole mechanism. We also want to authenticate this web server on the actual on the right hand side, just to make sure that they say who they say they are, right? And ultimately, we want to get to the point where we're setting up a secure, established secure channel so that we can send encrypted traffic back and forth between the client and the server. So let's start off here. So first of all, the client is going to send a so actually before we get there, the TLS, I'm going to break this down into two sections, right? The handshake part and the actual finish part, right? And it'll make sense in a minute. But for now, just think of it as actually two main sections to this whole TLS, setting up the TLS connection before getting to the established secure channel. So first of all, the client is going to send a hello packet. So let's put that in there. And basically this hello packet the client sends out, right, is basically saying, okay, that the TLS version it's going to use, and also gives a cipher suites supported, the actual suites of cipher that it's going to support, right? And it also generates a client random, which is a string of random bytes, right? It's going to send that over to the server. The server is then also going to send over a hello packet along with its SSL cert. So now we know the web server's public key from that certificate. And the server is also going to generate a server random, right? Which is basically a string of random bytes. So remember now, the client generated a random string and the server generated a random string. And that's important. And I'll get to that a little bit later on. But just for now, just think of that does happen there, right? So then what happens is the client is going to receive that hello packet. It's going to generate a pre-master key is going to generate, right? And it's basically going to send that over to the web server, right? So this is where we're going to have the key exchange. And basically what it is that, and also the client is saying, I'm finished part of this setup. And then the web server is also going to send a packet back, okay? And it's also going to say, I'm finished, right? So that's that again. Now, once that actually happens, okay, we then set up an established secure channel, right? But we moved a little bit faster. So the pre-master key, right? So the pre-master key the client generated on this side. So the pre-master key that it generated here, that it actually sent to the web server, there was a reason why it generated that and sent it over. So basically in here, what we do is we have the session key. And that's the whole point. We arrived at the session key, right? And that is basically an asymmetric key that is used to encrypt the traffic, sends it over to the web server, and it decrypts that traffic, right? So that session key is ultimately what we wanted to do. So each side had to generate the key in order for it to decrypt the traffic and encrypt the traffic. How did it come to that point, right? So basically what happened is the pre-master key was sent by the client. So we also have one over here. So that same pre-master key. And the way we generate, and the way each side generated this session key over here is that it took remember I told you that the client generates that client random number and sends it over to the server, and the server generated that random number. It took those two random numbers, the client random number and the server random number, along with the pre-master key. So it took those and it did a mathematical equation, right, at some calculation, and it arrived at the session key. Then the same thing the web server did, right? It took the client random string, it took its server random string, combined it with the pre-master key to generate the session key, and it uses that calculation, that Diffie-Hellman calculation. It's called a Diffie-Hellman calculation, and that's what it uses to generate that. So if you think about it very carefully here, that the key that's used to encrypt the communication that's flowing back and forth here, that key never went across the wire, right? All that actually happened was some random strings went back and forth along with a pre-master key, right, which is not the same thing as the session key, and each side calculated and arrived to the point where the session key actually was generated, right? So that's essentially what actually happened, right? And really, after this point, what you're really going to do is you're actually going to be saying, okay, you're now going to do your HTTP requests and your HTTP response all here at the established secure channel level, right? So that's all being secured now inside your TLS tunnel, right? So remember when I said to you, like this, the mechanisms of using the pre-master key, the client random, the server random, that is the actual mechanisms that RSA uses, right? And there's different ways, like different versions of Diffie-Hellman that actually uses that, and it can go into quite a lot of detail here, right? But there are subtle variations that does exist here, but I just wanted to highlight that it is the RSA method that I've kind of like explained over here. Now, just to kind of like put some little bit of nuances in here, it's just kind of like just some variations of different models here, right? That there could be, I mean, in this example here, there could be an example whereby when this packet came back here, right? This packet, this section came here back here, this one over here, it could have also included the server's digital signature. Okay, a digital server signature, right? So basically what that's now doing is encrypting basically some additional parameters, right? And if we did that, then instead of using the RSA model, we were using the ephemeral Diffie-Hellman method. So I just want to let you know that even though I explained it at a high level, there are nuances that just makes the things underneath the hood a little bit, complicated, right? But just to keep in mind that that does happen, right? So essentially, we've now created our TLS version 1.2 tunnel. It's secure. And we've agreed at the high level, the cipher suites that we're going to be using, the TLS version that we're going to be using, we established our session key. That's it. Thank you.